The world's energy supply is facing serious problems. Increasing energy demand caused by upcoming industrial countries like China or India, and the expected shortage of common energy sources will bring up new challenges for the future. One more problem caused by the world's rising energy consumption is pollution and climate change. These problems force the world to think about alternative energy sources. Currently, many opportunities are being explored by scientists around the globe. A promising one is the production of fuels from oil plants. Aside palm oil, rapeseed oil is one of the most important resources, especially in Northern America and Europe. The European Union formulated targets for itself and its member countries to tackle climate change, the so-called 2020 target. One of them is to have 20% of its energy produced from renewable sources by the year 2020. Biofuels from rapeseed could become a major step on the way to reach these targets. Let's have a look on how rape and rapeseed oil are produced. To use fuels from oil plants in a diesel-powered car without alterations, it has to be transformed into biodiesel. We'll also take a look on that process. Brassica napus, also known as oilseed rape, is a bright yellow flowering member of the mustard family. It is a natural mixture of cabbage and turnip rape that has its origins in the Mediterranean area. Nowadays, rape is grown in many countries all over the world. Leading producers are the European Union, Canada, the United States, Australia, China and India. Growing rape is a good alternative to corn, but farmers should pay attention to many things. Rape utilizes nitrogen very well, and for this reason it is a valuable plant for material recycling or organic fertilizers. It is also ideal for the soil. Optimal growth needs deep ploughing and after sowing well compacting. Thereby water losses are minimized. Many pests make pesticides necessary. Natural enemies are snout beetles, snails and pollen beetles. Plant diseases and weeds are also problematical. The only way to battle against these pests is chemical treatment. Once harvested, the seeds are cleaned and crushed in oil mills. They are treated with steam to break up the cell walls. During pressing, the majority of the oil is extracted. Including the following chemical extraction, more than 98% of the oil can be won. Finally, the oil is filtered and distilled. This oil can already be used in cars with specially altered engines. To make it usable for normal diesel cars, it has to be transformed into RME, also known as biodiesel. By adding methanol, the long molecules of the plant oil are transformed into shorter RME molecules. Glycerin is one as a byproduct and can be used in the chemical industry. So far, biodiesel sounds like the way out of the energy crisis. But however, where something positive, there are always drawbacks. To give an overview over the pros and cons of biodiesel, we'll have a look at the major arguments for and against this technology. First to the pros. Biodiesel is produced from renewable resources growing locally. For this reason, biodiesel has a tremendous economic value. It ensures the supply of energy in times of crisis and offers a reasonable use of overproduction in national agricultures. Even the drop-off is useful. The compressed plants are full of proteins and can be used as forage for farm animals. Furthermore, the fabrication of biodiesel shows an energy balance that is clearly positive. Depending on the usage of the co-products, the relations from energy input to energy output diversify between 2:1 and 3:1. This means that for each liter of biodiesel produced, up to 3 times more energy comes out than is put into production. The biodegradability is one of the great advantages of biodiesel. Biodiesel degrades by 99% in only 21 days. In this period of time, diesel produced from mineral oil degrades by only 72%. Furthermore, researches on ecological toxicity have also shown clear advantages for biodiesel compared to classical diesel fuel. When biodiesel is used, the emissions of unburned carbon, hydrocarbon and particles are much lower than the emissions caused by traditional diesel fuel. Another argument is the closed CO2 loop. When biodiesel is burned, only as much CO2 is set free as the plant has assimilated from the atmosphere while growing. Now to the cons. The increasing demand for oil produced from plants has negative impacts on the rainforests in Southeast Asia. In this region, more and more palm oil plantations are built for the supply of palm oil to meet European demands. This doesn't only cause damage to the environmental system of the rainforests, it also leads to very high CO2 emissions because of the slash and burn method used to cut down the forests and emissions from the ground. Calculations show that only to meet the increase in Austrian palm oil imports, approximately 5,000 hectares of rainforests were burned down. This caused approximately 5 million tons of CO2 emission. Furthermore, many of the plantations are built on peat grounds. The oxidations of the exposed grounds caused another increase in CO2 emissions by approximately 120,000 tons, which is 8 kilograms per liter of palm oil. From a macroeconomic point of view, the German Umweltbundesamt opposes the use of biodiesel. To be economically rational, the production of biodiesel has to be subsidized with a lot of public money. This capital, used to support other fields of research, could bring higher benefits by ecological measures. To sum it all up, biodiesel is an alternative energy form in a certain manner, as long as the cultivation of rapeseed is sustainable and as long as a neutral CO2 balance isn't exceeded, for example due to transportation of palm oil all over the world. But there are reasonable doubts that biodiesel can be the energy form of the future.